Hey guys, so today we're going to look at Rolle's theorem and some examples. So Rolle's theorem states that if I have a function that's continuous from a to b inclusive and differentiable on a to b exclusive, and if fa is equal to fb, then there is some number between a and b such that the derivative of that number is equal to 0. So in layman's terms, that just means if I have a continuous function from a to b that's differentiable, and I can draw a straight flat line between a and b, so fa is equal to fb, then there is some number between a and b that has a derivative of 0. So it's a local maximum, a local minimum, or just a stationary point. I have a couple of examples that we can go through. Alright, so here's the first one. I have a quadratic function on the interval 0 to 4. Now, if we substitute 0 and 4 in, they should both equal to 5. Feel free to prove that to yourselves. So the question is, can we apply Rolle's theorem and say that there's a stationary point between 0 and 4? Well, we can go through the checklist. So first things first, a has to be smaller than b. Is 0 smaller than 4? Yes. Awesome. And then the second thing, the function needs to be continuous from 0 to 4. Is it continuous? Well, if you draw the graph out, you'll see that the quadratic looks something like this. So yes, it is continuous. Okay, the third item, it has to be differentiable from 0 to 4 exclusive. And we know that quadratics are differentiable. So yes, it satisfies that condition. So then, yeah, we should be able to find a stationary point between 0 and 4. And we can have a look at this graph. You can see that the stationary point is the turning point there. Okay, next example. This time we have a tan graph on the interval 0 to pi. So tan of 0 is 0 and tan of pi is also 0. Can we apply Rolle's theorem? So first things first, is 0 smaller than pi? Yeah, it is. Cool. And then second thing, is it continuous from 0 to pi? Well, if we have a look at the graph, we can see that there's an asymptote at pi on 2. So no, it's not continuous. Therefore, it's also not differentiable from 0 to pi. So even though f of 0 is equal to f of pi, we can't apply Rolle's theorem and say that there's a stationary point in between them. And you can see that by just looking at the graph as well. Okay, well, thanks for watching.